In our next unit, we're going to be working through the first half of Chapter 10. And Chapter 10 deals with sequences, but primarily series, and we'll pick up with series in Section 10.2. We're going to start, though, here in 10.1 talking about sequences, and a sequence is simply a list of numbers. We label them a sub 1, a sub 2, and so on through a sub n and further. And each of those, a sub 1, a sub 2, and so on, is called a term of the sequence. The integer is called the index. So a sub 4 would be the fourth term in that sequence. We can think of sequences as functions. So 1 gets sent to a sub 1, 2 is sent to a sub 2, and so on. And an infinite sequence there is a function whose domain is the set of positive integers. We're going to look at a couple examples here, and then we're going to go through a whole bunch of definitions and theorems. But I don't want to get too far ahead of myself. We're going to look at this first example. It says, given that a sub n is defined as 1 minus n over n squared, find the values of a sub 1, a sub 2, a sub 3, and a sub 4. Well, it's just simply plugging in the index number for the n value. So a sub 1, let me try that equal sign one more time, is going to equal 1 minus 1, which is 0 over 1 squared. 1 squared is 1, 0 over 1 is 0. That's the first term. Second term, a sub 2, is 1 minus 2, which is negative 1, over 2 squared, which is 4. So that second term is negative 1/4. The third term, 1 minus 3 is negative 2. And in the denominator, we have 3 squared, or 9. So the third term, negative 2/9. And then finally, a sub 4. 1 minus 4 is negative 3. And in the denominator, 4 squared is 16. And you could keep going if you wanted to here, but that's how we can find values of these different terms of the sequence. Now, the second two examples are giving us some different terms of the sequence and asking us to come up with a formula for them. The first one, we get 1, 5, 9, 13, 17, and you can see the pattern here. Each time they're increasing by 4. This is actually a very linear sequence here, and to find the formula for it, in this case at least, you could think of it as finding the equation of a straight line. You could think of that first term of the sequence as the point 1, 1, if you wanted to, and the second term as the point 2, 5. Find the slope between them, which would be 4, and then plug that into one of the formulas for a straight line, and it would give you the formula for the sequence. You're going to end up getting a sub n equals 4n minus 3, and our n values are going to start with 1. So we say that n is greater than or equal to 1. And that one's actually very straightforward there. Like I said, it's following more of a linear pattern. Sometimes you might get something a little crazy. This next one here, it alternates between 1 and 0. So 1, 0, 1, 0, 1, 0, and so on. And this one, at first glance, you might say, how do we approach this? We're going to end up taking negative 1 and raising it to a power. That's going to help us here. Now, in this case, let me write this down. If negative 1 is raised to an odd power, it's equal to negative 1. But if negative 1 is raised to an even power, it's a positive 1. And we're going to use that to help us here. Since my first term of the sequence is going to have n starting with a 1, what I'm going to do is I'm going to start out by taking this -1 to n plus 1. So on my first term of the sequence, when n is 1, -1 is going to be raised to the second power. So it's going to give me a +1. And what I'm going to do with that is I'm going to take it and I'm going to add it to 1. So I have +1 plus 1, which gives me a 2. 2 divided by 2 gives me a 1. And that's going to hold for all odd values of n. So for the third term, -1 would be raised to the fourth power, giving us a +1. 1 plus 1 is 2. 2 divided by 2 is 1. However, for the even values of n, -1 will be raised to an odd number. So we have -1 plus 1, which is 0, and 0 divided by 2 is 0. So that would be the formula there. And again, n is greater than or equal to 1. I'm going to stop this video here. The next video that I'm going to do, I'm going to walk through the next few pages of notes, just briefly reading through some definitions and theorems. I'm not going to get to any examples till I get to the third video. So if you're somebody that's content to read through it on your own, you could skip that second video.